Hey everybody, thanks so much for joining us from Genes in Space. My name is Mark Bliss. The Genes in Space competition has asked for your questions, and we're here to answer them. So joining us are our Genes in Space experts that are here to provide some guidance. We have Pam Schmidt with us. Pam is a recently retired award-winning veteran educator. She's taught for 37 years in a middle school science classroom. Pam has a passion for orchestrating really authentic and engaging learning experiences for her students, and that contributed to her being named Colorado Teacher of the Year and also the winner of the Amgen Award for Science Teaching Excellence, as well as the Milken Educator Award. She continues to hone her teaching leadership skills. She's earned the National Board Certification by serving as a differentiation and thinking maps coach, as well as a STEM and JSON project trainer. Pam and her 8th grade science team have used Genes in Space as a framework for all of their genetics and also their astronomy units over the past 6 years. She's encouraged all 420 of their students to develop a proposal and enter the contest. She's also been assisting with virtual and in-person workshops for miniPCR and Genes in Space for the past 2 years. Welcome, Pam.
Thank you. Thank you very much. Wow. Sounds
Quite
like
the
I've been busy,
introduction.
huh?
Of course. So I was wondering, what can you tell us about Genes in Space, and what would you say that the benefits for teachers would be for participating?
Okay. Well, to put it very simply, like if you want a one sentence answer, Genes in Space is an ideas contest. So what that means, being an ideas contest, it means you and your students don't have to do any hands-on work to enter the contest. It can just be the proposal in writing. But what it does is provide students and teachers with an authentic vehicle to get excited about science and to participate in research that's relevant and timely. Of course, teachers whose students win at some level get some tangible prizes like biotech equipment for their classroom, which is really wonderful. But so very much more important is the deep engagement and enthusiasm that the contest can bring out in our kids. They get so excited when they're doing it.
If teachers are working with these students to get started researching possible solutions to genetic problems in space, where would they start? How might they help their students to get started with a Genes in Space proposal?
Well, where to start researching is going to depend a lot on what question the student wants to ask for their proposal once they've narrowed that down. And then you're going to have to just go online and find where that information is available. What genes do you want to research, or what proteins do you want to research? It does help for students to get an idea of what kinds of questions are currently being researched in space, or what difficulties we've already encountered with our astronauts in space. If you go to the Genes in Space website, it provides several resources along those lines. There's information, including information about the biotech tools and how they can be used. There's videos from scientists who are currently conducting space research. There's samples of previous applications and also videos of previous winners presenting their research. And then they also provide for both the teacher and the student additional space biology resources like the NASA Space Biosciences link and the NASA Gene Lab. Some other places I've used outside of Genes in Space, University of Utah does some great work with genetics. They have one called Learn.Genetics for kids and one called Teach.Genetics for teachers. There's one more source I haven't used yet, but it was Jackson Laboratory Education and Learning Resources is a good spot. I haven't gone to that one yet. But really, the best place to start is right there on the Genes in Space website under the resources tab.
So thank you, Pam. I think what we'll do is we'll list those resources for teachers below this video so that they can access them.
That's a great idea. Yeah.
I have a question from a teacher. They said that they've never used any of the biotech equipment in the Genes in Space toolkit before. They're a little nervous about trying it with their students. What support is available for teachers like this?
That's such a good question. And you'd be surprised how often I hear it. I can totally relate to that. My teammates and I were in the same boat when we started using Genes in Space. All of us are old enough. I know, hard to believe. All of us are old enough that we didn't do any PCR or gel electrophoresis or any of that in school. We didn't try it until the very first training workshop that we went to. But I promise you, you do not need to worry at all. Both the Genes in Space team and the people at miniPCR have so many support systems in place for teachers. And I'm just going to list them, and maybe you can list these in the question below too. First of all, they have a very cool tool you can use called Schedule a Demo. And you can get a 15 to 30-minute live video conference with somebody who will answer your questions, or they'll go over the equipment with you, or whatever you need. They'll help you plan a program that will work for you and your students. I mentioned earlier videos. There are videos of, in addition to the informational videos about content, there are videos of the scientists at miniPCR conducting each of the learning labs, so you know how to do it, as well as videos on how to use every single piece of equipment, which was, like I said, really important for us because none of us had ever done it. Now, for me, personally, I loved attending a workshop. I think it was a great way to get us excited about it and a way for us to find out, oh, these tools aren't so difficult to use. miniPCR has some upcoming virtual workshops. And what's cool about the virtual workshops is they only cost $25, and they send you out the equipment you need to use and you get to keep it. So they've got workshops on a little inexpensive version of a gel phoresis called a Bandit. And they've got workshops on a really cool fluorescence viewer called a P51 viewer. And they send you everything you need to do that. And then you participate in the workshop online, and then you get to keep the equipment. And then on top of that, everybody at Genes in Space and miniPCR is really very kind. We had a couple of times when we were first starting to do this where we were like, oh no, this happened. What do we do? And we just called over, and just calling, you can always find somebody there who will help, or sending them an email. They're super knowledgeable and very kind and understanding that, you know, you're working with 13-year-olds or 15-year-olds or whatever you got, and mistakes might be made. So they'll do everything they can to help make sure you get a really great Genes in Space experience. Don't be afraid. You can do it.
Awesome. Thank you so much. I'm actually on the support line today.
Oh,
For
awesome.
miniPCR. So
right. See, he's right there.
Yeah.
So
they might call
if
and
you
talk to
take
me.
off, we'll know where you went to answer a question.
I've heard from teachers that don't have time to give all of their students really detailed feedback on their proposals. How do you help your students refine their ideas?
Okay, and we actually have 480 eighth graders in our school. So each of us has about 120 plus kids. And so there's no way. You just can't go in once they're to that full proposal state. You just can't go in. And so that's another reason why we decided we would focus on the testable question part and leave the proposal writing up to the kids. And so when we get to that peer review stage, we print out their Google Docs that they've been working on with their proposals. And we just have them identified with a number. We just have the kids put their student number on there, so there's no name attached. And we do just a table. We pass them around the table, and they provide feedback. They do 2 or 3 on the first day that we do this, and they provide feedback on the form. And then the kids get their copy, because I've told my kids they can write right on the copy if they want. They can highlight things. They can, you know, do any kind of editing they want to do to give some hints, some clues. We talk ahead of time about how to give constructive and useful criticism, not to just say this sucks or, oh, this is terrible, or to say this is great, because that doesn't help you improve anything either. So we've talked about how to give useful feedback and how to be kind while you give feedback. Those are little mini lessons we do, because, you know, they're 8th graders. So then we give them all the feedback, and they have a chance to rework their proposal if they want, and we print them out again, and then do at least another maybe 3 or 4 times around the table.
I have another teacher here. They said that their students are in middle school.
Okay.
Do you think that it's worth it for them to apply to Genes in Space, even if they don't have much background in biology specifically?
Yes, yes, yes. 100% yes. Don't even be afraid of doing this with your middle school kids. It is fantastic. We have loved it. It has just changed how, and oh my goodness, the kids, it's such an experience for them. Yes, maybe their experiments they come up with aren't quite as sophisticated with their procedural ideas, but they come up with some absolutely amazing questions. They just get excited about sending an experiment in space, and it just opens their brain. Plus, they don't get hung up yet on whether or not their idea is perfect. They don't care if it's a weird idea. They want to try it. And so absolutely have the kids participate. And then as they get into high school, they get better background knowledge so they can either further develop the same idea that they had, or maybe they even come up with a better idea. So I'm working with our high schools and our other feeder middle schools to try to figure out a way, let's do these labs or do this idea at the middle school level. And then when they get to high school, in their biology class or in their astronomy class or in their tech class, whatever, and it doesn't really matter what class you do this in because it's all good science. Then they can continue that and enter the contest again because they can enter multiple times.
Pam, I just have one more question for
Okay.
you, which is, you mentioned that these students that you have love doing the pipetting and the hands-on part. How important is it for students to have that hands-on experience with equipment? A lot of teachers are saying that their budget doesn't really allow for buying PCR
Yes.
machines. Do you think that impacts the outcome and experience of Genes in Space, or the likelihood that their students are going to be selected as award winners?
So first of all, the students do not have to do any hands-on experience to enter the contest. You just don't have to. And they can write a winning proposal without having labs in class. Absolutely. We did that our first year because we got trained literally 2 weeks before the deadline. We didn't even know about the contest till 2 weeks beforehand. So we did that with our kids the very first year. Now, that being said, the kind of science teacher I am, I feel like having at least some kind of related activity, not necessarily with the Genes in Space equipment, but some kind of related lab activity does increase their engagement in the whole process, especially middle school kids. You know how they are. Now, that being said, let me tell you about a couple of things that sometimes teachers aren't aware of. Genes in Space and miniPCR have made some things available. They have some ideas for more affordable items. You don't have to buy yourself a PCR machine and a gel electrophoresis machine. One thing that Genes in Space has is the Lab in a Box loan program. And just for the cost of shipping, you get this really massive, heavy box. You get all the equipment you need, like 4 PCRs, 4 gel electrophoresis, all the pipettes, all the reagents, all the DNA, everything you need to do a lab. That's what we did our second year because we still had no equipment our second year. So we signed up to get the loan of the Lab in a Box. And it comes with this very cool lab that we still do because the kids really like it. Right now, if you go on there today, there is a link to get on the wait list, and you want to get on the wait list because as soon as you get on the wait list, then they'll notify you the day that the loan application becomes available. Obviously, they can't have enough equipment to give a loan to absolutely every teacher who wants it because, you'd be crazy not to. But they'll let you know then when those loans become available. I believe, if I'm correct, it's just shortly after the deadline. So this year, deadline mid-April, loan applications come available right after that. And then you got to remember that if any of your kids win, then you get some equipment for free for your classroom, which we did that too. So we just, from bits and pieces from everywhere. miniPCR has also developed a little gel electrophoresis machine called the Bandit, which is more affordable than the blue gels, much more affordable than the blue gels. What's really cool about the Bandits is that you can have the kids build them. They're that simple to put together. And then they really understand how gel electrophoresis works. That's a pretty cool one. They have another affordable tool called the P51 molecular fluorescence viewer. It not only works with DNA and RNA, but also with proteins and enzymes. So if you got some kids who want to test what happens to some proteins or some enzymes in space. Finally, miniPCR is also developing digital labs. I was just working with Dr. Katie Martin on one called Microbe Hunters, which is a Bandit lab, but now she's making it digital. Now, I personally, like I said, I would like to do hands-on labs, but the digital version called Microbe Hunters is really quite good, and it's available for free. I'm going to give you the website. You can go straight to the lab, but you can also, again, go to that resources tab, and it's if you go down to the bottom of the resources tab, it says digital. Click on that, or you can go to digital.minipcr.com, and that takes you right to the lab. It's already up there. It's free. I've already convinced my team over at school to use it as an additional opportunity for the students, because this time, instead of focusing on the lab procedure, they get more of an opportunity to focus on analyzing the genetic data. So it's a great lab. We're going to use it in addition to our hands-on labs. But if you can't afford the hands-on lab, this would be a good one. What do you
Pam
think?
Schmidt, thank you so much. Thanks for joining us. Thanks for
Of
sharing
course.
all of your many years of Genes in Space experience with us. Hopefully this is helpful to all those teachers out there that are
Oh, I
trying
hope
to
so
bring it to
too.
their classrooms. Thanks so much, Pam.
All right.